Hey, y'all, let's cover the Pythagorean theorem. This is section 1.4. Draw a picture for this theorem and write down the formula. Note that this formula can only be used with right triangles. And right triangles just means that there is a 90-degree angle in one of the sides. In one of the angles. There can only be one 90-degree angle. So you would see this cute little square here sometimes. In fact, that's usually the representation of a right angle. And to know it's what each side is, these sides here are called legs. And it doesn't matter which one you label them. There's leg A and B. I could label this one B or A, and this is leg B. All right. The last one here is leg C, and this is known as the hypotenuse. Hypotenuse. It is always the longest side of the triangle for the right triangle, and it is always directly across from the right angle. Okay. The formula for the Pythagorean theorem is just one of the little legs, so a squared plus the other little leg, b squared. I'm going to square that, and that's equal to the hypotenuse, c squared. All right. Well, let's keep playing. So this was a fun little thing. Finding which of these are actually the right triangles. This one's an equilateral, so that's a no. Isosceles, no. This one's a right angle, so this one's a good one. This one's an equilateral. This one is right here's the right angle. So that one's a right triangle. This one is as well. And this one is as well. This one, gosh, it's a tough one. It's an isosceles, though. It almost looks like one. But this one is right there. Cute little one. All right, so let's move to the next. Do you try at one point? This is a one, or do you try it, but still I'll go ahead and do it. Which one of these will represent 3 squared plus 3 squared is equal to r squared, which would be c squared, and if we're going to think of it properly. But they've got them listed as r, so I'm going to call them all c, because that's going to be representing of the hypotenuse. So the only ones we can do this with is right triangles. This is an isosceles, so that's not, and that's not. Well, no, that's an isosceles as well. So this is the only one. It can actually be 3 squared plus 3 squared is equal to c squared. All right. Let's actually find the hypotenuse using the Pythagorean theorem. In the triangle above, you're given the measures for the legs A and B. Leg A is going to be 5, and leg B is going to be 12, and these are inches. Makes me crazy if it's not written there. All right. So what is C? What is the hypotenuse? Well, A squared plus B squared is equal to C squared. They're saying A is 5 inches. We're going to square that one. Plus B, which is 12 inches. We're going to square that one and set them equal to c squared. So you cannot add up the 5 and the 12 and then square it. That's not the correct order of operations. You have to square the 5. That's 25 inches squared. Then you have to square the 12. So that's 144 inches squared. But what does this look like in your calculator when you do it? I know my calculator is not going to look like most of yours. So I have y to the x, where you might have what they call a caret. Okay. If you have y to the x, great. If you have x to the box, that's another one. So what you're going to do is you're going to take that 5, caret, square it, and equals. There's the 25. Take the 12. You're going to caret and square it, and that's 144. It's equal to c squared. Now we're going to add the 25 and the 144. So that's 169 inches squared is equal to c squared. Okay. Now, this is inches squared. That's representing area. That's not representing my hypotenuse, because it needs to be just in inches like the rest of the legs. So in order, and we need c squared to be a c. In order to get rid of a square, we have to do the opposite of a square, which is a square root. So square root, what you do to one side, you do to the other. So C will equal in inches. So in this case, I'm going to take my 169, and I need to find my square root sign on this one. Oh, there it is right there. Just Yours, you might have to hit square root, then 169 equals. But with mine, I was able to have the 169 and just hit my square root sign. Almost every calculator is different. So this is 13 inches. So to answer the question above, find the value of the length of C, the hypotenuse. Okay, the hypotenuse is 13 inches. All right. Then use your answer to find the perimeter of the triangle. Well, you know I'm going to make you find the area too. So the perimeter is just going to be 5 inches plus 12 inches plus the 13 inches. So the perimeter is, so that's 25, so 30 inches. All right, the last one, because I'm going to ask you to do it on the test, is tell me what the area is. And the area for a right triangle, for any triangle, is base times height divided by 2. Please feel free to use one of the other two if you prefer 0.5 times base times height. It's totally your call. My base is 12 inches. And my height is 5 inches. If you're ever in doubt, it's always going to be the legs, not your hypotenuse. So 12 times 5 is 60 inches squared divided by 2. So I'm just going to write the area is 30, 60 divided by 2 is 30 inches squared. Okay. Next victim, example 7. Now they're giving us the hypotenuse and they want us to tell, what is one of the legs that's missing. So we're looking for A. In order to find A, we're going to use the Pythagorean theorem again. So A squared plus B squared is equal to C squared. We're looking for A. So A squared, B is 6. What are these? These are represented in what? Centimeters. Okay, so 6 centimeters squared is equal to the hypotenuse, which is 7 centimeters, and we're going to square that. So in your calculator, 6 caret squared, 6 caret 2 is 36. You got centimeters squared is equal to 7 squared is 49 centimeters squared. We're going to solve for A. So we're going to just isolate A by getting rid of this 36 centimeters squared, subtract it from both sides. All right. So we get A squared is equal to, well, that's 13 centimeters squared. All right. If you'll notice in the question, it says write your answer in exact form and an approximate form. I'm going to show you both of those. The approximate form will be rounded because it will be a decimal, and we're going to round it to the nearest thousandths. So we're down to where we have A square, and that's equal to a centimeter square. We need to isolate and just solve for A. So the opposite of a square is a square root. What we do to one side, we do to the other. So A equals the square root of 13 centimeters. Please note that centimeters is not underneath that radical. All right. This is the exact form. All right. This is the exact length. That's all we're going to have to do, right? Perimeter of the triangle and the area, because we're going to have to do all of it. So the exact length of A is square root of 13 centimeters. Okay. The approximate length of A is, and that's just taking that 13 and taking the square root. So, and we're going to the thousandths place. So if you don't know how your places work, you've got from your decimal, let's go with 1, 2, 3, 4, 5. So this is your ones place here. The 2, just one place past to the right of the decimal, is your tenths place. Tenths. And then the 3 is your hundredths. And 4 is our thousandths. And that's as far as we're going to have to go. So if we're going to look to see what we're going to round this sucker to, we've got 3.60555. All right, so 3.6055. I'm just going to stop right there. We're going to round to this place right here, our thousandths. In order to do that, we have to look to one place over to the right. Here in my space. And if that number is greater than 4, so 5 or higher, then you're going to add 1 to the rounded number, the number we're rounding. So this is going to be 3.606. The approximate is 3.606 centimeters is the approximate form. So the next thing we're going to need to do is find the perimeter and the area. The perimeter is just the 7 plus this 3.606 centimeters. So I'll go up here. P equals 3.606 centimeters. 7 centimeters plus 6 centimeters. A little tough to see. All right, so 13, 14, 15, 16. So the perimeter is 16.606 centimeters. The area, and it's a triangle, so it's base times height divided by 2, or 0.5 times base times height. So the base is 6 centimeters, and the height is 3.606 centimeters. We're going to multiply those and then divide it by 2. All right. Do not leave that number in your calculator. It's going to be wrong if you do. You need to put what you've already rounded to and utilize that, okay? So 6 times 3.606 equals, and divide that sucker by 2, and so 10.818. The area is 10.818 centimeters squared, because it's area. All right, that's everything for that one. Let's go ahead. I'm going to go ahead and do the you try it. Find the length side. Actually, this is doing the exact same thing. I'm not going to bog you down with anything more on that. But I'm going to come down here and do example 8. This is a real world type problem. More likely what you're going to see, especially on my exams. If the owners of a house want to convert a stairway leading from the ground to their back porch into a ramp. Somebody wants lovin's. I've been gone all day. All right, the owners of a house want to convert a stairway leading from the ground to their back porch into a ramp. All right, the porch is 3 feet off the ground, and due to building regulations, the ramp must start 12 feet away from the base of the porch. So we've got a porch. So here's a house, and they've got a porch that comes off the house. And so that is 3 feet off the ground. Okay, 3 feet. And we need this to come out 12 feet based on regulations. So they're going to want to find out. I'm drawing this wrong. Hold on, y'all. I am drawing this wrong. So if we're saying it's 3 feet, I'm going to make it a little bit bigger too. 3 feet tall, 12 feet out. There we go. Now this is going to look more like a ramp. There we go. There's our ramp. And this is our right angle. All right. So what's the question? How long will the ramp be? So we're looking for the hypotenuse. We know it's the hypotenuse because it's the side directly across from the right angle. Okay. In order to find the hypotenuse, let's just whip out the Pythagorean theorem. A squared plus b squared is equal to c squared. Oh my gosh, you're making me crazy tonight. So 3 feet squared plus 12 feet squared is equal to c squared. 3 squared is 9 feet squared. 12 squared is 144 feet squared, and that's equal to c squared. We're going to add these two together, 9, 10, 11, 12, 13. So 153 feet squared is equal to c squared. Am I doing this right at this point? 10, 11, 13. Yes, okay. Take the square root of both sides. I don't think that's a perfect. Nope. So that's 12. What do they want to round us to the nearest 10th? So 12.4. So C is equal to 12.4 feet. All right. What are the questions? How long will the ramp be? The ramp will be 12.4 feet. That's it. Oh, sailboat. All right, this will be the last one I do for you. Sailboat is a large sail in the shape of a right triangle. The longest edge of the sail measures 17 yards. The bottom of the edge of the sail is 8 yards. How tall is the sail? All right. Here's my boat. Here's my sail. And they're saying that the longest edge of the sail, the hypotenuse, is 17 yards. And the bottom edge of the sail is 8 yards. How tall is the sail? Again, Pythagoreans. A squared plus B squared is equal to C squared. 17 is C, so 17 yards we're going to square. We'll call the question mark A. And B is going to be 8 yards, and we're going to square that. So A squared plus 8 squared is 64 yards square is equal to 17 squared, which is 289 yards squared. Okay, now we're going to isolate A by itself. So we're going to subtract 64 yards square from both sides. And that's A squared is equal to, well, there's a 5, there's a 2, and there's a 2 yards squared. We'll take the square root of both sides. When we do that, A equals 15 yards. The sail is, answer the question, sail is 15 yards tall. Okay, that's it for Pythagorean theorem. See you in the next one. Stop.